Hello, this is Warren Powell, and I'm going to speak today on sequential decision problems, from framing to modeling to solutions. This will be a presentation in 4 parts. This is part 1, Introduction to Sequential Decision Problems. I like to use this picture as sort of a tapestry of all the work that I've done over my career. I started upper left-hand corner in trucking, did a lot of work in trucking, various trucking parts of the trucking industry, railroads in the middle, air cargo lower right. I worked in manufacturing for materials scientists, ran an energy lab for 10 years, logistics, did a lot of work in health and e-commerce. Now, if we take a look, here's a set of boxes. Each box poses a question. The question is one where you need to make a choice, and I would like to make a best choice. Making that choice is a decision. So these problems are full of decision problems. Now, after you make a decision, information is revealed that you didn't know when you made the decision, and it's relevant to the performance of the decision. So let's go back, take another look. These are all different decisions. Pick out one of the boxes, put your eye on it. I go forward. That's the information that arrived relevant to that decision, but arrived after I made the decision. Now, decisions are often come in the form of sequences of decision, information, and the information that arrives after a decision was not known when you made the decision. So you have to deal with the uncertainty of what information might arrive. For example, an inventory ordering problem, you could order inventory, maybe it arrives right away, or maybe it arrives months into the future. After that point, you get information about the demand for the product, then you make more decisions, and so on and so forth. At my company, Optimal Dynamics, the blue circles are drivers, the squares are loads. I'm assigning drivers to loads, but loads are being called in over time, and I have to dynamically make decisions at any point in time, recognizing the impact of a decision now on the future. Testing new vaccines. You can make a decision about what dosage and which people to vaccinate, and then you observe how they respond and who accepts the vaccination. Financial trading, we're buying and selling different stocks and assets in the presence of evolving prices. Now, here's a problem that's often viewed as a static problem. I want to find the best places to locate my distribution centers and warehouses. I've got a manufacturing plant down in Mexico. But in fact, I don't just make this once. Even these decisions are made over time, and I have to deal with the uncertainties of changing demands and policies and that sort of thing. Now, here's one of the most common decision problems that everybody faces, making the best of a set of discrete choices. Now, over to the left, I have a number of examples where we have discrete choices like a product design or a drug or an advertising campaign. Sometimes it's discretized values of a continuous parameter like a price or a temperature or density. Now, the hard part here is maybe I have 2 choices, maybe I have 10, maybe I have 1,000. But what makes it hard is I don't know how well they perform. I have this uncertainties, and I have to learn about that over time. So these become a sequential decision problem where I'm learning. Okay, that's the end of part 1. This is a links page, and I hope to see you in part 2.